Hello, my name is Yunfei Hao. I'm from the California State University, San Bernardino. I'm going to tell you about our project on building a smart parking system on our campus. So on our campus, we have over 7,000 parking spaces, and there wasn't any parking monitoring system before our project. So we started with setting up a pilot project in one of our parking structures. Our objective is to provide real-time information on the number of available parking spaces in that parking structure. In this parking structure, we have over 700 parking spaces. That is about 10% of the total available parking spots on campus. Well, there are three parts of our system. The first component are the IoT-based vehicle counters. Those are the wireless battery-powered sensors that we bury them under the pavement. The second component of the system are the computer vision-based vehicle counter. For this part, we're utilizing the existing surveillance cameras that are pointing to the entrances of the parking structure. In addition to that, to get floor-level capacity estimation, we also utilized some of the cameras that are looking down the ramps that's going on to the second and third level. And the last component, well, just as all the smart systems these days, we build a web application to provide real-time information. Well, in this video, I'm going to show you what's happening with our system. So notice we're looking at the camera from here. When vehicles coming in the parking structures, the sensor will be triggered. And we notice the color in the sensor have been changed. And at the same time, our computer vision algorithms extract the vehicle from the background and tracking its movement direction. Well, there are quite a few challenges when building the system. For the sensor part, we built our own filtering algorithm to eliminate the miscount and the double count from the raw sensor inputs. So our sensors are essentially magnetic sensors. They will give you a reading once they detect the change of the magnetic field. We also built our own vehicle tracking algorithm. The reason for that is our cameras are not directly pointed to the gate. So many of the cameras are actually looking at the gate from an angle, and that causes some complexities when directly apply some of the vehicle tracking algorithms. So to illustrate some of the challenges, in here, one of the inherited limitations for our under pavement sensor is that it's very hard for the sensor to tell the difference between two vehicles moving inside the parking structure closely, as we're showing here in this tailgating scenario, versus one vehicle that is slowly moving into the parking structure. So from the sensor's perspective, the change of the magnetic field will look very similar. In this slide, I'd like to show you some of the challenges we're facing from the computer vision algorithm. So in this video, you'll notice that we're looking at the entrance from an angle. And at the same time, a large portion of the camera wheel is actually being blocked by this large SUV. We conducted an evaluation towards the end of the project, which shows that our system is performing well in terms of counting the vehicles. Well, to talk about some future directions that we're going to work on, one thing we can do is to provide not only the real-time counting information, but also do the parking prediction. We're also working on extending this project to cover the whole campus. Well, finally, I'd like to acknowledge the support from various departments on our campus. While this project cannot happen without their help and encouragement.